Hello student, I am Professor Devashish Bose, Head Department of Criminology and Forensic Science, Dr. Hari Singh Gaur Vishwavidyalaya, Sagar, Madhya Pradesh. Today I am going to present a lecture of BSc 5th semester on the unit Examination of Drug Part 3, that is Examination of Opium, which has been jointly prepared by myself and Ms. Neha Sharma, PhD scholar, a UGC JRF at Department of Criminology and Forensic Science, Dr. Hari Singh Gaur Vishwavidyalaya, Sagar. Let's start our discussion while taking a look at what we are going to learn today. Module 1, Introduction to Medico-Legal Aspect of Opium. Module 2, Sample Collection of Opium. Module 3, Preliminary Examination of Opium. Module 4, Confirmatory Examination of Opium. Module 5, Instrumental Examination of Opium. And finally, Module 6 will be our conclusion. My dear students, in previous lecture we studied about the introduction of opium. In this lecture, we will discuss on the topic examination of opium. You know the purpose of the forensic chemical analysis is to examine the crime exhibit for its identification, to give opinion to the criminal justice system. The term narcotic is derived from the Greek word narcotics, which implies as states of lethargy or sluggishness. Narcotic drugs are those substances which gives relief from pain and induce sleep but socially not acceptable. Narcotic drugs and psychotropic substances are of natural, semi-synthetic and synthetic in nature. Once into the body, they act on the central nervous system and produce an altered state of mind of the subject. They produce physical and psychological dependence which depends on the drug. Opium contains various organic and inorganic substances like alkaloids, acids, protein, sugar and inorganic elements. About 40 opium alkaloids have been known in the opium, out of which 5 are major. They are morphine, codeine, thebaine, papaverine and narcotine. The first 3 alkaloids are covered under NDPS Act of India. Morphine is the alkaloid which determines the identity and quality of opium. It should be more than 0.2% in the sample to be considered as opium. In relation to narcotic drugs and psychotropic substances, if any person is involved in illicit trafficking of narcotic substance like cultivating the opium poppy, engaging in the production, manufacturing, possession, sale, purchase, transportation, warehousing, concealment, use or consumption, import, interstate, export, interstate, import into India, narcotic drugs or psychotropic substances, or financing directly or indirectly any of the aforementioned activities, then he or she may be investigated under NDPS Act of India. Opium is one of the commonest drug of abuse. A large number of people are addicted to opium in different ways. This is very common and all of you must be knowing it. In villages, many people consume opium. Opium is also widely used for committing suicide. Many medical and paramedical professionals have committed suicide by injecting morphine along with skeletal muscle relaxants. Opium is also used as a cattle poison. Small children are sometimes killed by drugging them with opium. Since opium is eliminated in urine and feces, samples of urine and fecal material can be preserved in cases where stomach wash has not been given positive test. Before learning sample collection, let's take a look on some terminologies related with opium. Opium poppy means the plant of the species Pavver somniferum and the plant of any other species of Pavver from which opium or any phenanthrene alkaloid can be extracted. Poppy straw means all parts except the seed of the opium poppy after harvesting, whether in their original form or cut, crushed or powder and whether or not juice has been extracted from them. Poppy straw. Poppy straw concentrate means the material arising when poppy straw has entered into a process for the concentration of its alkaloid. Preparation in relation to a narcotic drug or psychotropic substance means any one or more such substances in dosage form or any solution or mixture in whatever physical state containing one or more such drugs or substances. The main purpose of sampling is to obtain a representative sample of the drugs of interest for their analysis. Reporting officers and assisted scientific staff are having the responsibility of it. Here, I am explaining you the sampling methods as described in the Directorate of Forensic Science Laboratory Procedure Manual, prepared by Ministry of Home Affairs, Directorate of Forensic Science, Government of India. Sampling method. The principal reason for a sampling procedure is to produce a correct and meaningful chemical analysis. Because most methods, qualitative and quantitative, used in forensic science laboratory for the examination of drugs require very small quantity of material. It is vital that this small quantity be entirely representative of the bulk from which they have been drawn. Sampling should be undertaken to conform to the principle of analytical chemistry also. Single package. The simplest sampling situation is where the substance item consists of a single package of material. The material should be removed from its container or wrapping and the net weight should be recorded or measured. The analyst should then visually examine the material to assess its homogeneity. Presumptive testing may be made at this stage if it is true that the sample of homogenization process will be lengthy or if there is still some doubt as to the identity of the material. For blocks, representative samples should be taken from all surfaces including the center region also, or else the total brick is grounded to a fine powder. For powdered material is placed in a clean clear plastic bag and shaken thoroughly. If the powder contains aggregates, the same may be broken down by passing through successive finer sheaves or by pounding in a mortar pestle or by using an adapted commercial food mixture or food processor. Alternately, coning and quartering techniques can be applied as follows. The sample is mixed by shaking or stirring. Large fragments are reduced if necessary. The material is then poured on a flat surface to form a cone. The cone is flattened and the material is then divided at right angles, forming quarters. Opposite quarters are taken for a sample. The remainder of the material is returned to the receptacle from which it was removed. Should further coning and quartering be desired to reduce the sample size, particle size are further reduced. The material mixed thoroughly, poured on to a flat surface and divided as before. More than one package. The analyst should examine the contents of all package by his simple naked eye and possibly by simple color test or TLC to determine whether all packages contain suspected drug, opium or crude morphine containing material, and or if one or more packages contains material different to that of majority of packages. The simplest indicator is the physical appearance of the material. If one of the more packages obviously differ in content, these should be segregated and subjected to separate analysis. They should never be mixed. The composition of multiple container items is as follows. If there are less than 10 packages, all packages should be sampled. If there are 10 to 100 packages, randomly select 10 packages. And if there are more than 100 packages, randomly select a number of packages equal to the square root of the total number of packages, rounded to the next highest integer. So, this is common as the statistics we follow. If the material in all the packages found to be similar by visual examination, one of the following two approaches may be applied. 1. the content of a number of packages may be combined and the combined bulk material may then be homogenized. Or alternatively, number 2, chemical testing may be applied to a number of each of the packages. When different type of materials have been identified in various packages, each subgroup should be composite in an identical fashion. Items containing bulk aggregates. If the aggregates can be easily reduced to small particles, then this should be the approach and sampling procedure followed as outlined previously. If the material cannot be easily broken down, maybe in some cases, random sampling should be drawn from at least 2 different parts of the item. Preliminary examination is the first step to analyze any exhibit. Positive result of these tests are only presumptive indicator for the presence of opium alkaloid. Don't consider it to be confirmatory. It is mandatory for analyst to confirm such results by using an alternative technique. Now we begin with the test. A. Marquez test. Take a small amount of suspected sample in the test tube and to it add about 10 drops of water. Crush the sample with a glass rod. Place a few drops of water solution through filter paper, supernatant liquid on a spotting plate and add a few drops of Marquez reagent. The development of purple-violet color indicates the presence of opium or crude morphine. Now I will read out the preparation of Marquez reagent. Take 8 to 10 drops of 40% formaldehyde solution, add to it 10 ml of concentrated sulfuric acid. B. Ferric salt test. Take small amount of suspected material on a spot plate and add about 2 drops of water. Titrate the sample until water becomes brownish color. Take a drop of this liquid to another part of the spot plate and add 1 drop of reagent. Appearance of brown purple color indicates the positive test for the presence of meconic acid. This meconic acid is present in raw and prepared opium, but it will not be detected in crude morphine. It is only test for opium. Preparation of ferric salt reagent. Dissolve 1 gram of ferric sulfate in 20 ml of water. Next, C. Ferric chloride test. Dissolve appropriate sample of opium in water and add a drop of dilute hydrochloric acid followed by few drop of 10% solution of ferric chloride. A red color appears. Divide this solution into 2 parts. Take first part and add dilute hydrochloric acid to it in excess and warm it. The red color of the solution remains there. Take the second part and add a solution of mercuric chloride. The color of the solution does not affect. Preparation of mercuric chloride reagent. Dissolve 5 grams mercuric chloride in 100 ml of water. Dilute hydrochloric acid, about 10% weight by weight of HCl in water. Porphyroxene test. Take a small amount of suspected material on a spot plate and add 2 drops of water. Triturate it with glass rod. Take 1 drop of brown liquid from this mixture to another part of the plate and add 1 drop of 2N-hydrochloric acid and heat gently. Appearance of red color indicates the presence of porphyroxene. Morphine is the main alkaloid of opium. Therefore, in confirmatory examination of opium, we will make crystals of morphine. Crystal test for morphine. Every crystalline material have specific type of crystals. The main purpose of microcrystal test is to identify the substance by the structure of crystal. In microcrystal test, we examine the test solution by comparing the crystals made by standard solution. Mercuric chloride reagent 5%. In this test, we will get bunch of crystals. Potassium calcium iodide reagent. In this test, we will get needle shaped crystal. Potassium iodide reagent 5%. In this test, we will get orange layered crystal. Thin layer chromatography. This technique is used as a screening examination tool for the examination of opium. Other instrumental techniques are gas liquid chromatography, high performance liquid chromatography or HPLC, and spectroscopic technique, which are used for the confirmation. Stationary phase is activated silica gel without fluorescing substance, TLC plate of 0.25 or 0.2 mm thickness. Mobile phase will be solvent system containing system A, toluene, acetone, ethanol and concentrated ammonia in the ratio of 45:45:7:3. System B, ethyl acetate, methanol and concentrated ammonia in the ratio of 85:10:5. System C, ethanol, chloroform, dioxane, petroleum ether, benzene, ammonium hydroxide and ethyl acetate in the ratio of 5:10:15:10:15:5. System D, ethanol, benzene, ammonium hydroxide and dioxane in the ratio of 5:50:5:40. Visualization method by ultraviolet light at 254 nm. Second method would be drag and drops reagent spray. Third will be acidified potassium iodoplatinate spray reagent. Preparation of drag and drops reagent. Mix together 2 grams of bismuth subnitrate, 25 ml of glacial acetic acid and 100 ml of water to produce solution termed as 1. Dissolve 40 gram of potassium iodide in 100 ml of water to produce a solution termed as solution 2. Mix 10 ml of solution 1, 10 ml of solution 2, 20 ml of glacial acetic acid and 100 ml of water. B. Preparation of acidified potassium iodoplatinate reagent. Dissolved 0.25 gram of platinic chloride and 5 grams of potassium iodide in water 200 ml. For the acidified version, 2 ml of concentrated hydrochloric acid is added. Gas liquid chromatography packed column technique. Detector FID, that is flame ionization detector, column 6 feet or 2 meter, internal diameter 2 to 4 mm. Packing 3% SE30 or OV1 carrier gas nitrogen at 70 ml per minute. Injector temperature 275 degrees centigrade, oven temperature 230 degrees centigrade, detector temperature 275 degrees centigrade, internal standard docosane or other N-alkanes 100 mg in 5 ml of methanol. Derivatizing reagent N-ortho bis trimethyl salicylatamide BSA capillary column technique. Detector FID column fused silica chemically bonded and cross-linked methyl silicon or methyl phenyl silicon such as OV1, SE54 or DB1. Film thickness 0.15 micrometer, length 25 meters by 20.27 mm internal diameter. Carrier gas will be hydrogen. Injection technique will be split mode ratio 1/60. Makeup gas argon at 18 ml per minute. Injector temperature 250 degrees centigrade. Detector temperature 280 degrees centigrade. Temperature program start at 150 degrees centigrade to 280 degrees centigrade at 9 degrees centigrade per minute. Then isothermal for 0.5 minute. Internal standard tetracosane or other N-alkanes. Salicylating reagent is N-methyl N-trimethyl silitrifluoroacetamide MSTFA. Gas chromatographic detector will be flame ionization column glass 6 feet into 2 mm ID. Packing 5% OV1 on 80/100 chromosome W-HP. Flow rate will be 25 ml per minute. Injector temperature 275 degrees centigrade. Column temperature will be 240 degrees centigrade. Detector temperature will be 275 degrees centigrade. With this, we come to the end of gas chromatography. Now we start with high performance liquid chromatography. Method 1. Column 300 into 4 mm ID packing material, cyanoalkyl silica HPLC 10 mm diameter, nucleosil 10 Cn or equivalent. Mobile phase will be ammonium acetate pH 5.8, 80, acetonitrile 10, dioxane 10. Flow rate will be 1.5 ml per minute. Detection at UV detector at 254 nm. Method 2. Column 300 into 3.9 mm ID packing material octadecyl silicane, Bondapac C18 or equivalent. Mobile phase will be water 40, acetonitrile 60. Triethylamine 0.1. Flow rate will be 2 ml per minute. Detection will be carried out using ultraviolet detector at 280 nm. With this, we come to the end of high performance liquid chromatographic technique, and now we'll start with another instrumental technique, that is spectroscopic method. First, we will look at infrared or Fourier transform infrared spectroscopy. Principal peak in kBr. Disc are morphine 805, 1243, 1118, 945, 1146, 833 absorbance. Codeine 1052, 1268, 1500, 1111, 793, 934 absorbance. Thebaine 1234, 1605, 1144, 1270, 1030, 910 will identify these compounds. After completing the infrared spectroscopic, now we will see ultraviolet spectroscopic technique for the identification of morphine. If you dissolve morphine in aqueous acid, the lambda max will be 285 nm, and if you make an aqueous alkali, it will be 298 nm. For codeine, in aqueous acid, it will be 285 nm, and in aqueous alkali, there is no shift. For thebaine, aqueous acid, the lambda max will be 284 nm, and when you prepare the solution in aqueous alkali, there will be no shift. Opium alkaloids may be studied by scanning the samples in appropriate organic solvent with the help of UV visible spectrophotometer also. The spectrum and the value of lambda max of the spectrum can be compared with the standard value. Now, with this, we come to the next instrumental technique, mass spectrometry. Principal peak of mass by charge for morphine will be 285, 162, 42, 215, 286, 124, 44, 284. For codeine will be 299, 42, 162, 124, 229, 59, 300 and 69. For thebaine, it will be 311, 255, 42, 44, 296, 310, 312 and 174. With this, we can easily identify and distinguish these opium products. Here we discuss about the different instrumental examination of opium on the basis of Directorate of Forensic Science Laboratory Manual prepared by Directorate of Forensic Science, Ministry of Home Affairs, Government of India. Since opium and its alkaloid are narcotic substance and produce dependence, therefore illegal activities may be carried out by the people to earn more amount of money. Moreover, opium is illegal drug except some legal medication such as morphine and hydrocodone. Government made control of it, still these activities are running. As a result of this, Narcotic Bureau get different illegal opioid substance and their examination is very necessary. Legally, allowance to produce opium is given by United Nations Single Convention on Narcotic Drugs under supervision by the law enforcement agencies of individual countries. In India, opium was collected by farmers who were licensed to grow opium poppy. The price of opium paste is fixed by the government according to the quality and the quantity tendered. Some farmers diverted small fractions in black market. From there, they earned huge amount of money. Black marketeers convert opium into its derivative like heroin and earn more money by selling it to illegal drug market. For the examination of these substances, we forensic people follow methods like presumptive test, confirmatory test and instrumental technique, which will be discussed in the lecture. Opium is a Schedule II drugs under the Controlled Substance Act of USA, while most opioids are Schedule II, 3, 4 and 5 drugs. Some drugs that are derived from opium such as heroin are Schedule I drugs. According to this act, Schedule II drugs can be used for medicinal purpose with the restriction and written prescription is required with no refill for purchasing the drugs and their addiction is severe. As addiction is very dangerous for society and social world, being the student of forensic science, let's aware the addicted people and their family about this evil and tell them how to get rid from it. Educate them, motivate them and give support to them so that they can be able to live normal and joyful life. With all these information, here we come to the end of today's lecture. Do keep in mind what we have discussed today. It's time for you all to do some self-study. This is Professor Devashish Bose signing off. If you want to learn more and enhance your knowledge, you may log on to our website for MCQ, quizzes, LOR at www.cec.nic.in. Till then, goodbye and thank you for giving a patient hearing.